Hello there. We're going to look at a pretty straightforward statement and see if we can prove it. So for any lines, A, B, and C, so for any three lines that are all located in the plane, this gets a little bit different if you're doing it in any other kind of space, but just in the plane, and we know that A and B are parallel, and we know that B and C are parallel, then we're going to show that the first and the third, A and C, must also be parallel. This is called transitivity of parallel lines. So, like many things, start with a picture. So again, this may seem pretty straightforward. We know A and B are parallel, they're never going to intersect. We know B and C are parallel, they're never going to intersect. What is not so clear is, does that force A and C to also never intersect and be parallel? And that's what we're going to show. So to do this, we're going to need a transversal. I'm going to call it T, and it's going to intersect all of those. And now what we're going to do is we're going to break up a couple of those angles. So I'm going to call this angle up here, I'm going to call that angle 1. And that's on the upper right portion for that intersection. Now over here, also in the upper right portion, I'm going to call this angle 2, and over here I'm going to call that one angle 3. So let's start our proof. I'm going to start with the given that I'm going to use first. I'm not going to list all the givens, I'll use them as we need them. A is parallel to B, and what that means is that angle 1 is going to be congruent to angle 2. And that's because of the parallel line postulate. Now let's go over to B and C. Those lines were parallel, that was a given, and we can again look at the upper right portions for both of those. Those are corresponding angles, and they're also going to be congruent. And again, that's because of the parallel line postulate. So now we have angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. So we can conclude that angle 1 is congruent to angle 3 by substitution. If you want to be really technical, it's actually because of the transitive property that this whole side's equal or congruent to this whole side, which in that is equal or congruent to that, so you get that transitive property there. Or you can say substitution. I'm okay saying substitution here. I'm not gonna stand on that though. Like if somebody insists that it's transitive property, it actually is the transitive property. So we were able to show that this is congruent to that parallel line postulate, and this is congruent to that because of parallel line postulate. Therefore, this is congruent to that by substitution, or the transitive property, which means that this is a corresponding angle for A and T, matching there to 3 with C and T, so A and C must be parallel. And they are parallel because of the parallel line postulate. We got those in corresponding angle format. All right, our proof is done. Character and Scholarship for Life.